6.5 has to do with factoring special cases. On our flowchart, there's going to be some cases where we are unable to factor a quadratic because it's not a trinomial or because the leading coefficient is not 1. These quadratics might still be able to be factored, but there might be a different process. So the first thing you want to ask yourself is, did we factor out a GCF? Because if you factored out a GCF and the leading coefficient is now a 1, you can hop back into the chart. If you factor out a GCF and the leading coefficient still isn't a 1, then you want to do that. So make sure you're factoring out a GCF first. Then I'm going to multiply. Well, first let me say, if I have a quadratic, it's ax squared plus bx plus c. So I'm going to multiply a by c. That's going to be step number 2. So a is the term on my something squared, and then c is my coefficient. I'm sorry, my constant. Then I'm going to look for factors of a times c, whatever that number is. So if a was 3 and c was 5, I'd be looking for factors of 15 that add or subtract to b. And I decide whether they add or subtract based on the rules from my original flowchart. So if the second sign was negative, I would be looking for signs that subtract. If the second sign was positive, I'd be looking for signs that added. So now I'm going to rewrite b in terms of the chosen factors of AC, and be careful with your signs. Again, the same rules apply. So if my second sign is positive, my signs are going to be the same, and I look to the first sign for that. If my second sign is negative, my signs are going to be different. I look for the first sign to tell me the sign of the bigger number. So you really need to know those signs. And then I'm going to do factor by grouping. So I'm going to do an example of that. So let me find, I'm going to scroll to where it says factoring trinomials, a is greater than 1, and I'm going to do this example right here. So in this case, I look at example number 1, and it says 3p squared minus 2p minus 5, and I want to factor it completely. Well, in this case, I don't have a GCF, so that was the first question I had to ask myself. So in this case, it's a quadratic trinomial, my leading coefficient is not a 1, and there's no GCF. If I was following my chart, I'd be dumped into a special case category, and that's okay. Because here's what I'm going to do. If this is ax squared plus bx plus c, I'm going to take a, which in this case is 3, and c, which in this case is 5, and multiply them together to get 15. So now I'm going to look for factors of 15 instead of just 5 that subtract, because my second sign is negative, to 2. So my choices here are 5 and 3. So now what I'm going to do is rewrite negative 2p in terms of 5p and 3p. So I recopy the 3p squared. And now I'd ask myself, since my second sign was negative, my signs are going to be different. This tells me the sign of the larger number. So it's going to be a negative 5 and a positive 3. So now I rewrite this as negative 5p plus 3p minus 5. So all I did here was rewrite negative 2p as negative 5p plus 3p. If you were going to combine like terms, you would get negative 2p. I just changed the appearance, I didn't change the value. It would be like trading a $5 bill for 5 ones. Same value, different appearance. Now I'm going to do what's called factoring by grouping. So I'm going to take the first 2 terms and factor whatever they have in common out. So in this case, they both have a p, and what I'm left with is a 3p minus 5. Now I take the last 2 terms and I factor something out of there. They have nothing in common, so I put a plus 1 and I do 3p minus 5. Anytime the terms don't have something in common, you must factor out a 1 or a negative 1, and you're going to decide that based on the signs. Because if you notice something here, what I have in parentheses are the same exact thing. 3p minus 5 and 3p minus 5. So technically, I'm going to factor a 3p minus 5 out of these. 3p minus 5. And what I'm left with for the first one is a p. And what I'm left with for the second one is a plus 1. Essentially, I take my matching terms and I dump them into 1, so that 3p minus 5 got dumped into 1, and my leftover pieces get dumped into another parentheses, and that is my final factored answer. This is called factoring by grouping. I'm going to do another example so we can see it again. I look at this one and I ask myself, is it a quadratic trinomial? It is. The leading coefficient is not a 1 and there's no GCF, so I'm in the special case category. In this case, A is 2 and C is 9. That means that A times C, 2 times 9 is 18. I'm going to read the signs now and my knowledge of the signs. Since the second sign is negative, I'm looking for factors of 18 that subtract to give me 3. So my factors of 18, 1 and 18, 2 and 19, 3 and 6. So I'm going to use 3 and 6. All right, back to my signs to get another clue. The second sign is negative, so it tells me they're going to be different. And then I look to the first sign to tell me the sign of the larger number. So the first one, the bigger one, needs to be positive, so plus 6 and minus 3. So now I'm going to rewrite 3n in terms of 3 and 6. So I recopy the 2n squared. I use plus 6n minus 3n minus 9. Every time you do this, you should be checking, is 6n minus 3n 3n? Yes, then I just changed the appearance. I didn't change the value here. And now I'm going to factor by grouping. So I take something that the first two have in common out. Okay, they both have a 2 in there and they both have an n. So I'm left with an n plus 3. And now I'm going to take something out of the second two. I'm going to take out a negative 3. And I'm left with n plus 3. Be careful with your signs. This should happen every single time where these two in parentheses match. If they don't, you might have done something wrong with your signs, or it can't be factored by grouping. But if you can rewrite the middle term, then there's something wrong with your signs if you can't get it into anything like this. So every single time, these two should match. Because now I'm going to factor them out. They're what they have in common. So I take out an n plus 3, and what I'm left with is a 2n minus 3. I got those from right here. This and this both get dumped into here, and that's my term. This is my final factored answer. If I wanted to check this, what could I do? If I wanted to check this, I could multiply these these binomials together and get an answer. It should match my original. Okay, I'm going to go back to the bottom of the notes here where it says the difference of two squares. If the expression is a binomial, so how many terms in a binomial? If it has two terms, we can look for perfect squares. If we notice that both the terms are perfect squares and the sign in the middle is a negative, remember we're talking about the difference of two squares, we can factor by following another process. So if you have something that's a perfect square minus something else that's a perfect square, you can rewrite that as the perfect square of the first one plus the perfect square of the other, perfect square of the first one minus the perfect square of the other. So let me show you that example right here. I look at this and I ask myself, is it a quadratic trinomial? No, so it's a special case, and this is a special case right here. It's a difference of two squares. So this first one, 16 is a perfect square. The perfect square of 16 is 4. Perfect square of n squared is n, and the perfect square of 9 is 3. So I'm going to write this as 4n minus 3 times 4n plus 3. And that would be my final factored answer. Look at the next one, number 2. 4m squared minus 25. Perfect square of 4 is 2. Perfect square of m squared is m. And perfect square of 25 is 5. So I write it as 2m plus 5 times 2m minus 5. Remember, that's the exact same thing as writing it like this. The property that allows us to do this is the commutative property. We can change the order and still be the same. So really it doesn't matter if you do the positive first or the negative first. Really, I'd like you to focus on multiplying a times c, rewriting it as a factor of b. There are some other methods to doing this where people use guess and check, but I'd really prefer that you learned how to use this because then you don't have to worry about playing guess and check. It's really going to be essential, so keep practicing, do these two examples, and then try a few on your own.